With deep appreciation for your visionary guidance and outstanding leadership, yes, we're gonna talk aerospace with MAPAL. I got Michael waiting inside right now because the details of what they're doing here for the R&D side of aerospace just might blow your mind. So let's go take a look. Michael, good to see you,
Tony,
my friend. Thank you so much for allowing us to bring cameras in here.
Great to have you.
One of my favorite subjects is aerospace. I mean, the world of aerospace is, from my side and what I've seen, somewhat complicated at times.
It can be, yeah. Challenging, complicated, among things, yeah. For
We
sure.
need people like you in our lives to help uncomplicate some of those issues.
Yeah, okay.
And to my knowledge, we have some demos and stuff that we're going to go over today on camera that are going to resolve, hopefully, some complications for other folks. But before we get to the machine, that nice DMG Mori over there, let's kind of start with what I'm looking at here, because rivets, from what I understand, and I've filmed at a couple of aerospace companies, can kind of be a pain, and a lot of people, or all people, are still doing it by hand.
Yeah, either by hand or on a drill motor, a portable drill motor, because it's done at aerospace final assembly. And you're going to have mixed material stacks, which is extremely challenging. You have to drill it with one tool, so you're going through carbon fiber, titanium, aluminum, things like that.
One tool.
With one tool.
That makes sense.
Yeah. If you can do it, it's great.
So we wanted to offer that little teaser because we have a machine in the back that we want everyone to see.
Correct.
To uncomplicate. I'm not even sure if that is a word, but I've used it at least 3 times now. But before we get there, and before we get to these demos that are mind-blowing as well, let's talk about the reasonings behind why you started this facility in 2018.
So MAPAL in the United States is well known in the automotive industry, and cost per part normally is the motivating factor to, you know, bring innovation to the market. And innovation is in our DNA. The aerospace market is a little different. That's going to be safety being a top priority, with process consistency being the focus. So because of that, it's very difficult to bring new ideas and solutions to the market, especially with the OEMs who are doing final assembly.
I can honestly say I'm very grateful that safety is a priority as much as I fly.
Yeah, there's a reason it's as safe as it is. So.
Yeah, and with all the cars being made, I'd like safety to be there too, but I understand that it's price per part there. All right, I'm excited because I've seen ahead of time. I get a sneak peek before I do this. But Michael, let's step over here. Let's look at what's going on inside this machine. There's a couple of really fascinating demos because this is about R&D. This is about making processes better for folks. And sometimes you get some requests that seem incredibly difficult, but that's what this area is for.
Correct, yeah. So I have 2 examples here in the machine. The first one, it's going to be the one on the left. It was for a Tier 1 supplier, and they were having issues exceeding the exit burr requirement from the OEM, and they were having issues from the first hole, and that was causing them to have to go back and manually remove burrs from thousands of holes in a shift.
Aye.
So we took on the challenge. We requested material, we made tools, made a fixture to hold it, did testing, optimization, delivered a report, tools and the workpiece material back to the customer. So from start to finish, from the inception to the delivering a fully custom solution for them, was less than 2 weeks.
All right, Michael, hold on. You took a process that was giving them hardship on thousands of parts in less than 2 weeks?
Yes. And so in all of our testing, the results of that, we never exceeded 50% of the maximum allowable burr. That was testing here. The customer determined that the tool life was over 10,000 holes per tool. So they went from deburring from the beginning to not having to do it for more than 10,000 holes.
That's incredible. I don't know this answer. You might not know this answer either, but did they ever give you feedback on how much time was saved there?
Yes, so we investigate that. Sometimes it's offered voluntarily by them. What we typically are going to ask, because we're interested.
I want to know.
Yeah, for sure. And that helps us, because then it helps us bring it to others in the market. Right. So.
Super cool, Michael. I like that spot that you said also 50% of the requirement for that.
Right.
Because obviously before it wasn't passing at all.
Right.
And then you didn't even make it to that 50% mark. So that's really cool. We have a second part here as well. I first looked at this and immediately got giant cartoon eyes. And I said, Michael, are you getting ready to try to make a full slot in this material? And you actually said yes.
Yeah. So we actually had a request from a OEM. And they were using a 3/8 inch composite router to full slot cut 1 inch thick unidirectional CFRP material, which is a challenging task. The request from them, though, was to increase feed from 60 inches per minute to 100 inches per minute, so a 40% increase in feed.
All right, again, I got to take a step back, Michael. Someone's asking you to increase the speed on a process that is already difficult to do, if even possible to do. Now, is this process already been proven? Were you able to do it? And also, what are some of the complications in a process like that with this material?
Well, so it's in the machine, so we obviously had good results. But we basically, in-house, we developed an optimized geometry, made tools, did testing, and ultimately that optimized cutting geometry made it into one of our standard product offerings. So this affected the global product offerings. But challenges with something like this is, well, obviously we had to make the tools stronger, more stable, and still tried to maintain the cutting performance itself. And we're talking about surface finish, delamination, where the fibers, the layers want to come apart, and we experienced none of this in our testing. So
I've had issues like that as well. Some of my experience, I've ripped the different fibers apart and wondered how to make it better. I think it's really cool what you just said, Michael, that this was an R&D test, that you were able to help the customer out. It's obviously in here because we're sharing it for a reason, but then it became a global product that helps others as well. Isn't that the true gift of the R&D areas?
No, for sure, for sure. And it goes both ways. We have other R&D locations throughout the world, and we all communicate and share this information. So.
And we're going to have another video on that as well, because they do have a great team here at MAPAL discussing with other places around the world to make sure these things are done correctly. All right, Michael, we gave a teaser at the beginning. We talked rivets. We talked about some of the pain that can be with 3, 4, 5, I don't know, what was it, 3 materials, right?
Right.
I was just going to exaggerate a little bit like I do sometimes, but 3 materials, same tool trying to drill through all 3 materials, and you have a machine back here. There's only 2 in the world of its kind. There's nowhere else in the world.
Right.
Can we take a look?
Absolutely.
Come on, guys, let's take a look. Michael's going to show us something that maybe we've never seen before. I had never seen it before. We definitely want to focus on some of the software area side as well, because what we're looking at and what we're learning, I think, is incredibly fascinating. But when I first walked in here, Michael, I looked at our friend Dan. I was like, what in the world is this? And I have seen hundreds of machines in thousands of shops around the world and had never seen this.
Right. Yeah, so this piece of test equipment is a Metis ADU test bench. An ADU, it's often used in aerospace final assembly. It means advanced drilling unit. It's a portable drill motor. They move it from fixtured point to produce a hole in a workpiece whenever they put 2 sections together, for example. And the test bench itself is actually measuring the cutting forces that the workpiece is experiencing. And that gives us great insight into the actual performance of the tool, instead of just measuring the workpiece after the fact. So. And
these results are then displayed here?
Correct.
And allow us to pretty much know how to optimize a very difficult situation.
Right, so say if you're having issues with diameter and you notice that the torque measurements go really high after a certain depth, that can, conclude that maybe the tool's wearing out faster than expected, it's wearing in and it's work hardening the material, such like in titanium or something like that. So.
Can I ask you a kind of a pickier question? And everyone who watches this channel, sometimes I get questions that pop up just based on the person I'm interviewing being super intelligent and wanting to learn from them. When I picture running through 3 materials, and I myself from a programming background think of this, In order to solve some of these issues, are we changing speeds and RPM as we go through? Are we just trying to plunge through and find a tool that can do it all?
Well, so
I see that you're smiling about this.
Yeah, I was going to talk about it. Traditionally, these ADUs are pneumatic. So they have a fixed feed and speed and stroke for a given configuration. In order to change, you have to change gearboxes and stuff. There are some offerings in the market now which have CNC control. So some of our customers use that and they like that, but they're not as portable. All you need to run this is going to be an airline. So yeah, absolutely. In the case of an electric drilling unit, you could change feed and speed to optimize for those particular materials.
That's fat. And if I'm a human trying to do this on my own, am I just trying to gauge the vibration and the feel like I would on a manual machine of some sort, right?
Well, the good thing about this is, you move it from a fixture point to a fixture point, and it does all the work. I'm not pushing this into the part or anything like that. Now, they still do manual hand drilling in aerospace, which, again, for safety reasons, that sounds crazy, but they do it. They do it often to get into an area where you just can't get a drill motor or a CNC machine or a robot or something like that. So, yeah.
It's really cool. All right, we're going to close this thing out, Michael, but I want to leave this moment for you because we talked a little bit about the creation of this facility in 2018. We showed a couple of demos of what you're working on and the complications that come with that. A unique machine that's only 2 in the world. But I want you to talk to the audience a little bit about, look, if you have this issue, if you have this problem, if you want to reach out to us, this is how you do it. We're happy to help you. Those kind of things as a kind of a closing statement for everyone.
Right. So if you have a MAPAL representative, a salesperson, or a point of contact, reach out to them. They'll get in touch with the test department, and yeah.
That's pretty much how it works.
That's pretty much how it works.
You're making it too easy. Hey. We want it to be that easy for everyone watching.
Right,
though,
correct. Right.
Oh, awesome, Michael. Thank you so much for your time today. This is an area that when these cameras shut off, I'm staying because I want to spend more time in learning how this all works.
Let's do it.
Awesome, Michael. Thank you all for watching. We appreciate you. Only 2 machines in the world like this and those demo parts. Oh my gosh. So if you have an issue, give Michael a call. Give the folks here at MAPAL a call. They can help you sort out those details. This is that almost 75 years in business, 3rd generation, family-owned company that loves the difficult things and then providing a solution. I mean, you heard it. 2 weeks, a solution that was something that couldn't even be done previously. Absolutely amazing. Michael, appreciate your time, my friend.
Not a problem. Thanks for having me.